Hello and welcome. In programs solving real life problems, the execution of instructions doesn't take place in a sequence, and the sequence of execution must be altered depending upon the situation arising at runtime. Control statements are used to alter the execution sequence of a program. There are situations where instructions must be executed repeatedly. This is called looping. Sometimes the required number of repetitions will not be known in advance. The computation simply continues until the logical condition results in false. In many other occasions, during the program execution, a particular set of instructions are carried out depending upon the result of a logical test. If it is true, a group of statements is executed, else some other set of instructions is executed. This is called conditional execution. There are certain special conditional execution in which a group of statements is selected from several available groups. This is known as selective execution and is implemented using switch statement. Break and continue statements are used to alter the normal execution of loops. Break is also used with the switch statement. C provides several control statements. In this lesson, we shall learn about the control statements and discuss their usage. Let's examine a problem of calculating the sum of square of digits from 1 through 9. How would you calculate the sum? You'd start with digit 1, calculate its square. Then take digit 2, calculate the square and sum it with the result of previous step. This is repeated until you reach digit 9 as shown in the flowchart. The steps of calculating the square, adding the result of this step to the previous step and checking if you have reached the digit 9 needs to be executed repeatedly. The logic can be implemented using a loop to calculate the sum. Let's see how this can be implemented in a C program. Loops in C can be implemented in three different ways: the while loop, the do while loop, and the for loop. Let's discuss these constructs further and see how the sum of square problem can be solved using different loop constructs. A while loop consists of two parts: an expression which controls the loop and a statement block which is executed repeatedly. The statement can be simple or compound, but it must include a statement which alters the value of expression which controls the loop execution, thus providing a stopping condition for the loop. In the code snippet, the statement block calculates square of a digit and adds the result to that from the previous step. It also increments the value of the variable digit. The instructions in the statement block is executed until the value of the variable digit is less than or equal to 9. Once the value becomes 10, the logical statement results in false and the loop breaks. In the implementation with while loop, the test for continuation of the loop is carried out at the beginning of each pass. But sometimes it is required to pass the loop at least once, irrespective of the outcome of the test for continuation. This can be achieved by using do while loop. The statement block is executed repeatedly until the value of the expression is true. Notice that the statement will be executed at least once since the test for continuation is done at the end of the loop. As in the case of while loop, the statement block must contain a statement which alters the outcome of the expression such that the execution of loop terminates. Note the implementation of sum of a square problem using the do while loop and understand the difference between the two implementations. The for statement is the most commonly used looping statement in C language. I would recommend to use the loop instead of while and do while loop, as the construct includes the initialization expression for the loop index, the expression for test for continuation, and expression that alters loop statement at the end of each pass. The for loop is written as shown in the example. Expression 1 is used to initialize the index that controls loop repetition. Expression 2 represents the condition that must be satisfied for loop to continue execution, and expression 3 is used to alter the loop index. As shown in the example implementation, the expression 1 is an assignment expression, expression 2 is a logical expression, and expression 3 is a unary expression which increments the loop index. A loop embedded inside another loop and control of execution of each loop is carried out independently is called nested loop. Let's understand the nested loop further with a real example. Let's assume we have a 4x4 matrix of integers and we want to compute sum of numbers in each row. Firstly, we define an array variable of type integer and initialize it with the given integers. Then, the logic is to take a row and traverse through the cells adding the data items to a variable which holds the sum, and print the sum once the data item in the last cell is added. These steps must be repeated for all the rows one by one. The logic is implemented with nested loops with index I and j. The variable sum stores the sum of integers of a row. The outer for loop is used to traverse the rows and the inner for loop traverses the cells in the columns. When the outer loop index I is 0, the inner loop with index j traverses all the cells in the row and adds the number in each cell one by one. At the end of the execution of inner loop, the sum of all the numbers in the first row is calculated and is stored in the variable sum, which is printed on user's console with the help of printS function call. Then the next line character is printed so that each sum is printed in the fresh line. When the outer loop executes next pass, the outer loop index I points to the second row. The variable sum is cleared of the previous result and the integers in second row are added. This continues for all the rows and cells, and sum of each row is calculated and displayed. The nested loops can be implemented with while and do while constructs also, or in any combination of the three loop constructs. If-else statement evaluates the logical expression, and if it is true, the instruction block defined for the if clause is executed, else the block with the else clause is executed. The if-else statement can be executed to evaluate more than one logical expression with else-if block. The else-if block is the same as the if block with the logical expression to evaluate and a compound statement to be executed. The if-else statement can take the simplest form where else-if and the else block of the construct is omitted. In such case, the instruction block is executed if the logical expression evaluates to true, else the statement following the if block is executed. The if-else statement can be nested one inside the other. Here is an example of if-else statement which may be used in an ATM machine for cash withdrawal logic. The logical expression checks for account balance against the withdrawal amount, and if the account has sufficient balance, the cash is dispersed and account balance is updated. If the account doesn't have sufficient fund, the else block is executed. In else block, the logical statement checks if overdraft is allowed. If allowed, the cash is dispensed and account balance is updated. else the withdrawal is declined with an error message. Do you remember the code snippet to determine grade depending upon student's score in conditional operator lesson? How would you implement the construct using a if-else statement? Give it a try. Switch is used when a group of statement is to be executed from several groups of statements. The construct of switch is as shown. An expression is defined with switch clause and group of statements follow with case level. The expression in the switch statement is evaluated and the statement group is executed whose case level value matches the value of the expression. The expressions used in the switch case statement must result in an integer or a character. One group of statements may be labeled default. This group of statement is executed if no case level matches the value of the expression defined in switch clause. A group of statement in switch can be labeled with more than one case labels. The group of statements under each case level must end with a break statement. If the break statement is omitted, the execution follows on to the statement of the next case level. The example shows the implementation to update the command and the state of EEPROM state machine. The command and state are changed based on the command issued by the user. The single-lettered command is read and stored in a variable tchar. A group of statements are executed based on the letters R, W, and E by the case labels. If the command is invalid, the statement group labeled by default is executed. Note, each statement group ends with a break statement. It alters the execution sequence and the control jumps to execute the first statement after the switch block. Break statement is used to terminate the execution of a loop or exit a group of statements in switch. A break statement can be used in for, while, and do-while loop constructs. It provides an easy mechanism to implement loop termination in case of error. Continue is used to skip the remainder of a loop and control jumps to the next pass of the loop. As break statement, continue can be used with for, while, and do-while loop constructs. However, as break, continue does not terminate the loop execution but only terminates current pass and starts the next one. Goto statement is used to alter the sequence of normal program execution. The control is transferred to the statement defined under the level specified in the Goto statement. The level used in the Goto statement must be unique and the target of the Goto statement must be defined inside the same function as the Goto statement. Generally, the usage of Goto is discouraged as C language provides better construct to implement branching and conditional execution. With this, we come to the end of this lesson. I hope you must have enjoyed it. Thank you and have a great time.